This is question number 24th objective solved example. Now in this question it is given that slope of tangent drawn to a curve. Suppose we have this curve y equals to fx and there is a point x comma y on the curve. Now if I draw tangent to this curve at a general point x comma y, then slope of this tangent is represented by f dash x, or we can say dy by dx, right? We also call slope this as a slope dy by dx, or sometimes we say gradient. So in this question, gradient at a general point x comma y drawn to the curve is given equal to this, right? So we can say dy by dx equals to x square plus y square divided by 2xy. Now what we are supposed to find is the curve fx whose gradient it changes like this, and also additional information is given that this curve is passing through 2,1 point, and whose gradient at a general point equals to this. Now see, this is if you see conic, there's nothing conic section involved here. Only when we solve the curve and we find fx, the answer will be a conic section, or you can say this is the property of a conic section, that how gradient changes like this. So I don't think there's anything that is the conic concept we can use in this question, anything in conic that we use to solve this question. So for some of you wants maybe you can leave this question right now, because this kind of we have to solve. This is a derivative relationship, we have to find y. So we have to go reverse of differentiation, or we can say anti-derivative. This is derivative, we have to find y, we have to find anti-derivative. Reverse of differentiation known as integration. So we have to integrate this, but not exactly integration. There is a topic known as differential equation. We'll have to understand the topic also before we can understand this fully. This is a differential equation. A relationship between x, y and derivative is known as differential equation of order 1. Why order 1? Because the highest derivative term is first derivative. Had it been d square y over dx square involved, we would have said differential equation of order 2, because it's a second derivative. Only first derivative is involved, so it's a differential equation of order 1. Now the way we solve this is will be taught to you in differential equation topic, and obviously we'll have to integrate here also. That again also we have not done. So I'll just try to briefly tell you how to do this, but if you're not able to understand, that's totally understood. You can come back to this question after you have done integration and differential equation. So the way we solve this equation is, I'll briefly give you idea, and standard thing, you don't have to think like this. It is a homogeneous differential equation. Homogeneous. Why we say homogeneous? We say homogeneous because you can express this differential equation in y by x form or x by y form. I can divide both sides by n and d by x square, and this is how I can express this differential equation, by dividing n and d by x square term. So whenever you can, if it is possible to write this expression of x and y in the form of y by x or x by y, then we say differential equation is homogeneous differential equation. And the method we use to solve homogeneous differential equation is we put y equals to mx, or in the solution let's use y equal to mx. The different symbol is used in the solution, but I feel comfortable with them, right? So now we need to change the variable of integration. Now y, in place of y, will have this m is changing, x is changing, so we need to replace the value of dy by dx to change y. We differentiate this. Product rule, derivative of x is 1 taking m constant, x constant, derivative of m, dm by dx, and you know product rule of differentiation, right? So we'll change the shape of this differential equation, the face of this differential equation. We replace dy by dx by m plus x dm by dx, and this is 1 plus m square divided by 2m. Now it should now rest is it is x into dm by dx. We bring m to this side, take LCM, it is 1 minus m square over 2m, right? This we can write as dm. After simplifying, we shift m terms to one side and x to other side. Now this is something you will study in integration topic, right? We have to remove this derivative term, we integrate both the sides, and integration is something you will do in integration topic, and it's also very easy. Just have to, you would have done in physics maybe the basic integration. I put minus sign here, I apply minus sign outside. Now derivative of denominator is numerator, so I say ln mod of 1 plus 1 minus m square. It's a formula, right? If derivative of denominator is numerator, then integral is log of denominator, and same here, plus constant of integration. Now if you simplify this, right, you cancel the log term, you write c as some log of some k and combine these two. So what we are getting from this side is right, log of 1 plus m square plus log of x, I'll shift this to this side, plus log of k equal to 0. That is 1 plus m square, sorry, it is 1 minus m square, 1 minus m square into x into k equal to 0, right? So we can write this as 1 minus y by x, y square by x square, oh sorry, it's 1. Log of this equal to 0 means this quantity is 1, right? Equals to k by x. Right, we take LCM to get x square minus y square equal to kx, and answer is, you can see, is something which is a conic section, right? That's why this question is there in conic section, but there's nothing related to conic section in the question. So briefly I'll go through this. In this question, slope of tangent is given in a general form, in x and y form. So from this we get this differential equation, a relationship in derivative, and now we are supposed to find y. From derivative we are supposed to find y, and the way is the integration way. But in between we have this topic differential equation, where we express differential equation in the form that we can integrate. So according to differential equation, it's a homogeneous differential equation because all the terms of x and y can be expressed in y by x form, and in homogeneous differential equation we replace y equals to mx to solve. So this is something very typical in differential equation topic, and once we have at the integration level, we integrate it. And integration is simple. If you have done in physics, you know, you can understand, otherwise you can wait till the integration topic is covered.